Hello and all. Today we will discuss about electronic circuits from case study DC analysis of transistor circuit by rayanibalaji. DC analysis of a transistor. The Q point represents a steady state DC voltage or current with no signal applied at a designated transistor terminal. Variations in current and voltage occurs around the Q point in response to a small AC input signal voltage. With all these, the transistor operates as a current controlled current source. When doing DC analysis, all AC voltage sources are taken out of the circuit because they are AC sources. DC analysis is concerned only with the DC sources. We also taken out all capacitors because in DC capacitor functions as open circuits. For this reason, everything before and after capacitors are removed, which in these circuits includes resistors. Below is the schematic of the circuit above with respect to DC analysis. Common collector voltage, common collector resistor, emitter resistor, resistor 1 and resistor 2. DC analysis of BJT amplifier circuits using the common emitter amplifier circuit shown in the figure as in the example. The use of equivalent circuits assists with the analyzing circuits. DC analysis of a common emitter amplifier circuit begins with determining the DC bias values and then removing coupling and bypass capacitors by the load resistors and the signal source to produce a DC equivalent circuit by applying Thevenin's theorem and Kirchhoff's voltage law. This is the common emitter amplifier circuit, common collector voltage. This is the transistor, one capacitor, second capacitor, and third capacitor. These are the grounds. Resistor 1, resistor 2, resistor 3, resistor 4, resistor 5. As AC analysis of a common emitter amplifier circuit begins by recognizing the capacitive resistance Xc remains very low at the signal frequency by considering Xc as equal to 0. Reducing the circuit to an equivalent circuit requires replacing the three capacitors in the circuit with effective shorts. Then the analysis continues by replacing the DC source with the ground from the perspective of AC analysis. A DC voltage source has internal resistance of 0 ohms. Since no axis voltage can develop across the DC source, it serves as an AC ground. Electrically, the AC ground and actual ground exist at the same point. All this reduces the equivalent circuit to three resistors and transistors. Connections and AC voltage source to the input of the circuit because the AC source voltage has no internal resistance of 0 ohms. The source voltage appears at the base of the transistor. Finding the AC signal voltage at the transistor base requires combining the source resistance Rs, the bias resistance, and the AC input resistance at the base to produce the total input resistance ring TOT seen by the AC source connected to the input. Using the voltage divider formula, the signal voltage at the base of the transistor VB equal to RIN TOT by RS plus RIN of TOT into VS. Thank you.